5. Suppose that a hole is drilled through the center of Earth to the other side along its axis. A small object of mass m is dropped from rest into the hole at the surface of Earth, as shown above. If Earth is assumed to be a solid sphere of mass m and radius r, and friction is assumed to be negligible, correct expressions for the kinetic energy of the mass as it passes Earth's center include which of the following? In order to determine the kinetic energy at Earth's center, we need to consider the potential energy of the mass Earth system at the beginning of the hole. Given that the gravitational force is not constant, the only way to determine that is by having a function for the gravitational force and integrating to bring the mass from the zero potential energy, which is likely at the center of Earth, to the end of the hole. From Newton's law of gravitation, we have that the force is equal to G times m prime times lowercase m divided by lower r squared. Here, m prime represents the amount of mass below the location of mass lowercase m. If we assume that the density of Earth is constant, the two masses are proportional in the formula mass divided by volume, m prime over 4/3 pi lowercase r cubed. This results in the relationship m prime is equal to m times the ratio of the radii to the third power. If we substitute this into the force equation, we obtain a function for the gravitational force that is linear and depends on the distance from the center. G, capital M, lowercase m, over capital R cubed times lowercase r. This confirms that the position for minimum potential energy is the center of the Earth, where the force has a value of 0 and we have stable equilibrium. When we integrate, we go from a radius of 0 to a maximum radius r of g m m over r cubed r dr, and the result of the integration is g m m over 2r cubed times r squared. When you evaluate the integral, you get option 3. And since the force is conservative, we know that all potential energy converts into kinetic energy, so that is your correct answer, option C.